Hello, everyone. Since morning, we had an amazing session about deploying models, like learning new about like what's coming in ONNX and ONNX runtime. Now let's talk about how do we deploy these models on device. Next 20 minutes, we'll talk about like taking this ONNX model, optimizing it, quantizing it, and running it all through a SaaS platform. So before we start, let's think for a second how many times like we are using AI throughout our day. Whether it is like using camera or charging your phone or taking a Teams call. For example, like this meeting is as well, like using segmentation or in any way AI. Some of these use cases are running on cloud and some of these use cases are running on device. And that's exactly our goal. Our goal is to make intelligent computing everywhere and accessible. So before we begin with our mission, let's think about why on device. Everyone, like I think many of you have this question, running a model on device, like on cloud, it's very easy. You just take a model, you train a model, and you deploy. That's it, right? So why bother running a model on device? Trust me, by end of this presentation, you'll be convinced that running a model on device is actually easy, and it doesn't take that much of an effort. So let's look into what are some of the key criteria for developers that are incentivizing running models on device. For example, cost. When you take a model, let's say you're an app developer and your app is scaling to, let's say, millions of users, and at that point, your cost of inference is exponentially growing. For example, ChatGPT's training cost was much lower than inference cost. So as a developer, if you're running a model on device, it's much cheaper because you're not paying anything. Second and most important is user privacy. Running model on device, that means the user data is never leaving a device. And that is like very concerning for like most of our customers. And as a developer also, we should have privacy-centric mindset when developing something for customers. Third and I think maybe a very important criteria is performance. And not just performance like for the sake of performance, but also for very good UX perspective. For example, taking one photograph on your phone runs around 25 to 30 different models. And this you cannot ship on cloud. You have to run these use cases locally on device. Also like to throw in the fourth one, that is accessibility. For example, let's say you want your drone to follow you when you are biking somewhere, and let's say you're biking on a very remote location. You want your drone to follow you and like not fall anywhere else. And in those cases, running a model on device where you don't have any internet connectivity makes total sense. Now let's say we know, like we all are convinced that, okay, running a model on device makes sense. But what does it mean to run a model on device? Whenever you are running a model on device, you typically have one of these three backends in mind. And depending on your application, you might want to run it on CPU, GPU, or NPU. For example, as a game engine developer, you would like to reserve your GPU for rendering purposes. And in that case, you might want to offload some of your ML workloads to CPU or some of the workloads to NPU. And in that case, knowing upfront how your model would look like really helps you navigate your complex use cases, where you can cater some of the use cases to CPU. And for example, maybe audio use cases, you can cater to CPU, and you can run like more intensive applications, maybe by quantizing to NPU, where you get like good throughput, and you can parallelize your workloads. When we started, we looked into what are the challenges for deploying models on edge. It's not as easy as, okay, you take a PyTorch model and you just run it. The first stage, and I think most of the developers like stuck there, is unsupported operator. With the latest supports coming in ONNX, we are really thrilled that this will be further improved and the gap will be minimized. But even if you are able to convert your model, you might not get very good latency. Your app might crash because maybe memory issues or some other issues. And maybe you're not able to quantize your model. And all of these issues can be summarized into three categories. One is getting started. How do you find right model for your use case? Even though you find the right model, how do you convert your model? Let's say you're able to convert your model. How do you ensure your model is performant on all the use cases that you're catering to? For example, a typical developer targets an audience of maybe, let's say, last 3 generations of the hardware. So just targeting your new model and your use case for latest and greatest hardware doesn't really add up. You also have to cater and think about maybe last 2 generations of the hardware. So whenever you're developing something, you do want to make sure your model is performant on all those devices as well. And third and most important use case is rapid iteration. How do you ensure your changes in your model architecture you can quickly test and verify, and you're confident that your use cases are satisfied? To solve all these problems, we built Qualcomm AI Hub. Qualcomm AI Hub is a SaaS platform that has more than 45 cloud-hosted device types that ranges from IoT, automotive, mobile, IoT use cases. You can bring your own model, and we have more than 175 pre-optimized AI models. So theme is more about you go to Qualcomm AI Hub, you pick up a model that serves your use case, and if you don't see your use case listed with pre-contest, pre-optimized model, then you can also bring your own model. And all it takes is 5 minutes and less than 5 lines of code to run a model on device. This makes Qualcomm and Snapdragon platform the default platform for on-device AI. Let's look into developer workflow for AI Hub. This is a typical AI Hub developer journey where you pick up a model, you'll bring your own model, or you take a pre-optimized model from AI Hub. Then you select a target platform. For example, you can choose, let's say, mobile platform. And then you pick up runtime. You have a ONNX runtime as an option. You have TF Lite as an option. Or you can directly go to QNN native runtime as well. And once you pick up a runtime, all it takes is run your model on a SaaS platform. And note that your model is being converted, compiled down to the selected platform and selected runtime. And then it runs on cloud-hosted real device. It's not running on any simulation or emulator. It's running on a real device, and then getting you back results. Once you're happy with model accuracy and performance, your model is ready to deploy. We have more than 1,400 companies using AI Hub. And these are some of the apps that are recently built with AI Hub, and they have very tight coupling, and they have built on top of AI Hub. They integrate, they have their CI/CD sometimes to build and make sure their model iterations are correctly and they don't regress. Would be happy to have more apps using AI Hub, and that will be listed here soon. Last year, we expanded our ecosystem. We are working with model makers. For example, Llama is always available on AI Hub. That is, you can export your own. We have scripts so that you can get access to Llama model, and then you can run scripts from AI Hub models to export your own Llama variant for Snapdragon devices. We also have preferred networks, IBM Granite models on Qualcomm AI Hub ready to use today. We also support TensorFlow, PyTorch, and ONNX as a framework. And as a SaaS platform, we also work with service collaborators. For example, you can train on Amazon SageMaker, and then you can deploy models using Qualcomm AI Hub. Let's look into what exactly is happening internally. So this will be divided into 2 stages. We'll just look into high level, what exactly is happening as a SaaS platform, and then we'll go into deep dive about how does Qualcomm AI Hub concepts about compilation, quantization come into play. So at the higher level, as we talked, you have a model, or you can bring your own model. Then you pick up a device. For example, you have mobile, compute, or XR devices to select from. And then you select runtime, for example, ONNX, QNN runtime, or LiteRT. And on a SaaS platform, you pass in these 2 variables, and then we convert, optimize, quantize, and then we procure a real device to run your model on. And the loop here on conversion to download optimized model is kind of a rapid iteration. So you can basically always do back and forth. You check the performance, you're not happy, you go back, and then you maybe run few more jobs on Qualcomm AI Hub. You're happy with the performance, you're ready to deploy your model. And all it takes is to basically download an optimized model, download an SDK, and integrate. We also have sample apps to get you started. We have sample apps based on ONNX runtime. We have ONNX runtime C++-based sample apps for Windows. And we also have a bunch of sample Android apps to show, for example, Llama as a demo. let's look into what exactly is happening under the hood. So developer brings their own model. For example, let's say they're building like float 16 model. Let's assume it's a PyTorch model for this use case. The first stage is optimizing your model. And here you convert, you pass in a digit-traced model to AI Hub. And AI Hub will be convert your model to ONNX. Then it will do ONNX to ONNX transformation.